Hello and welcome to the C++11 Beginner Tutorials by Gamer2Creator. I'm Chris. So now that we have the homework out of the way, we can move on. As you see on the screen, I've deleted all the old code. I left these headers in here. We don't need them right now, but we might later, so I'll just leave them there. But we have our empty function, our main function. Now I know that I haven't talked about functions, and we're going to be getting to those soon, but I wanted to introduce objects first, because it might be a little confusing learning to use functions with built-in types, and then suddenly object-oriented programming comes along and changes your entire way of thinking about it. So we're going to do object-oriented programming first, but very basic. First thing we're going to do is we're going to make a vector class. Now we're not talking about the STL vector class that is really just an array class that manages an array. We'll get into arrays. But this just holds a vector of two floats, which is an arrow in 2D space. You can consider what's at that arrow to be a position or an offset from a position, or whatever you want two floats to mean. But usually you would write a vector class. Now if you're going to be doing any 2D or 3D games, things of that nature, you'll be using vectors all the time. We're going to call ours a vector2f. That means a vector of two floats. First you put class. This is a keyword in C++, and it means that you're declaring your own type, and it's called a class. And then, real quick, you put two brackets, a beginning bracket, and an ending bracket, and then a semicolon. Now, anything inside of these two brackets is part of the class. Now, in order, excuse me, we're going to have to use the public keyword, and my computer stopped working. The public keyword just makes whatever follows it public and can be accessed from outside of the class. You don't have to understand that in detail yet. Just know that if you're going to want to be able to access the X and the Y, that it needs to be public. And we'll get into more of public and its other brothers and sister keywords. So now that we've defined a vector2f, we can use this pretty much anywhere that you would use an int, a float, a character, or any of the built-in types. So we can declare one. We're going to call it my vector. Now this is just like doing int, my int, or float, my float. That I'm just declaring a variable of this type. Now, what is this variable? Well, it's whatever we defined it to be, which is two public floats of x and y. Now that we've declared it, well, how do we manipulate these two floats that are inside of it? It's very simple. My vector dot. You can see IntelliSense popping up and giving us some very useful information. We have an x and a y. And it even says that they're floats and that they're public and that they're inside the vector2f class. So we want to assign x to something. So we have x, and now we say equals, let's just say 1.0. Let's do the same for y. So now we have a my vector that is of type vector2f. It's not just a float. It's actually a vector 2 with 2 floats inside of it. Now, what we can do with this is we can represent information as a single entity. And like I've been saying, that a vector, the idea of a vector is an arrow that points in a 2D Cartesian space. And that's an idea, it's an object all of itself. And the whole idea of object-oriented programming is to create a class that represents a real, tangible object. And then you put your data inside of it, and then pass this around your program as one. Otherwise, we would have to do something like this. And then if it was a 3D vector, oh, we'd have to create another my float z equals 1.0. And you'd have 3 variables here to represent a 3-dimensional vector. When we've just cut it down using object-oriented programming, to actually just one. We just have one variable. It's my vector. That's the name of our variable. Now when we get into functions, this is going to become very useful, and that's why I wanted to get basic object-oriented programming out there. This is fundamentally similar to a C++ struct. I'm not going to talk about structs, just because, I mean, they're basically this, a class that's public. But now that you know that you can create a type that's filled with the built-in types, you can also do something interesting. You could have one of your types inside of another type. So let's do something like, let's pretend that you have a player. You're building a game, you have a player, and he has a position in the world somewhere. But you need to represent this somehow. Well, this is what vectors are for. We're going to create a class player, because a player is a real object that we're trying to represent in our program. We're going to make it public. And now we're going to say vector3f position. Now what I like to do is put an M there. This is completely optional. It's a style choice. To me, this means it's a member. It's a member of a class. And it also allows you to, since the M is there, if you were to later pass a position into this, you wouldn't have 2 names that were exactly the same. And we'll get into that later. But now that our player has a vector that we're going to use as its position, we can now, I'm going to delete all this code. This is just getting in the way. We can now have our player. We're going to create our player. Then we can set m position dot x. Oops. Excuse me. The player dot m position dot x equals 1.0f. Now this looks like a lot of typing. I get that. But we're not using functions yet. But this is the idea of object-oriented programming is that we have a sentence here almost. You can almost read this as an English sentence stating what it is. The player's position on the x-coordinate plane is 1. The player's position on y is 1. And the same for z. So this allows you to put the thoughts in your head that, oh, I need to create a player for my game and he needs to have a position, and you can model that out in your program. And then you can continue to build these classes up with more information. For example, we're going to need a direction. And we're going to need to know if the player is alive or dead. We're going to need to know all sorts of things. First, we can create a bool. We're going to call it M is alive. Now we can set this, the player.m is alive equals true. And again, you can see how this starts to read like an actual sentence. The player is alive is true. Now you could do something like while the player.m is alive, which is the same as, I'm going to comment this out, which is the same as saying the player.m is alive equals true. So while the player is alive, then you can run your game. And also, we can create a vector 3f in direction, and then this would represent the direction that he's facing, things of this nature. You can add whatever code you want in here. But as you can see, while we have a 3f, the 3f is really only made out of floats. And when you really boil it all down, you're still just left with ints and floats and bools and the very basic built-in types, only you're using them inside of classes to represent groups of them together to form real objects. And you can pass these around as objects. For example, so far we've only made one player. We could make several. And now these two objects are exactly the same as in what they contain. They're both defined as two vector 3f's of a position and a direction, and M is alive. We've only set this one up so its position and its is alive is true. And we would need to set this one up as well individually. Just like that. Now, since we have, in these situations where you see this 1.0f, that's obviously a 1.0 float. That's what the F stands for. And we're assigning it to the X float. Now, think of the float as an object in of itself. And the same with the bool. But also do it with the player and the vector inside of the player. So instead of setting up X, Y, and Z all by itself, one at a time, we could actually do, I'll do it to the other player so you can see them both. We'll create our own vector 3f. We'll call it position, or pos for short. Then we'll do pos.x equals 1.0f, pos.y equals 1.0f, and pos.z equals 1.0f. So now we have a position vector, and we're going to assign this to the player's position vector. But we're going to do it to the other player, not the player, if that was confusing. So, since the vector3 class is an object of and of itself, we can assign it as an entire object. So I'm going to cut and move this up to the player code. And you can see the two different ways of doing this, where we created our player, and then we accessed its position.x and set it to 1. We did the same for y and z. Here we created our other player, and then individually and separately we created a position vector, set it to 1.0 for each x, y, and z, and then assign the entire vector of position to the entire vector of other player's position. And this is object-oriented programming. It's the idea that you can actually use more than just base types, but your own types that are made up of base types, as if they were a type that was already built in. Like, for example, here we use the equals operator on a vector and another vector. You can do this in C, at least not with classes. So our code is getting much more complicated. But fundamentally, all we've done is create the idea of two objects, a player and a vector. And the player can use the vector, and then later we actually create a player. Because while we've defined it here, we didn't actually create one until this line right here, and then we created another one here. Now all this is going to come together when we show you functions, because whenever you call a function, you have to pass it something, some data for it to use, to do work with. And that's when objects will really shine. I would encourage you guys to play around with this as much as possible. What I did when I was learning was I would just pick an object in the world and then display some of its traits as data to a computer, so the computer can understand. Like class person. So now we have the generic idea, the abstract idea of a person. Now, what are some common traits of a person? Well, they have an age. I'm going to call it M age. They have a, a wage. That looks weird next to age. Salary. Let's call it salary. What else do they have? How about a weight? We'll call it a float. Weight. And we're going to create one of these. We're going to get rid of this. We're going to create a person. And we're going to call it, I don't know, Chris. We'll name it after me. Alright, so I have Chris.weight. I weigh about 180, 190 pounds. And since I used the float, we could say 0.5. And we're going to put a little f there so it means float. Otherwise, this means double. This means float. This means double. If there's no f here, then it just defaults to a double. Alright. Chris.mage. I am 27. And I make not much. We'll just say, we'll make this 50. $50,000. Alright. But what else? I have a name. I gave my variable my name, but I could have just abstracted it and called it person or employee or something. But I have a name, and it's Chris, and it's C-H-R-I-S. Each one of those is a character. Together they form what's called a string. And since we have introduced object-oriented programming in this, we can actually create strings now. We have our string class. And I'm going to introduce this separately real quick. String. This is technically in the std namespace, but since we have using namespace std, we can delete this. We don't need this. And it's pretty wise to go ahead and do this most of the time, because if you're writing a substantial application, you're going to have to write std : a lot, and this will save you some typing. So we have our string name. Now I can assign this to Chris, just like this, with this string literal. Between two quotes, this is a string, and it is stored in the string table, something that's an implementation detail. Another way to do this, we can do this on two different lines. Name equals Chris, whatever. So now this string holds 1, 2, 3, 4, 5. 5 characters, C-H-R-I-S. But then there's another one. It's called a null terminator. It's sort of hidden because it's implied in this string literal. But just know that there will always be one extra character that's a null terminator. So this is how you do strings. This is the basic use of a string. But we want our person class, for every person that we create, we want him to have a name, or her. So we can actually put our string in here. I'm going to put an M there just for a member. So we have the name. Remove this, and it actually becomes part of our person class. And there you go. So now we have represented a person in code. You can add whatever you want to this. Now we're going to make this a little more useful in a work environment. We can change this to employee. So now we don't have person, we have employee now. And then we'll just put this as employee. It does not have a capital for an E, so this is not the type name. So now you see that our class is a little bit more abstract. It's a little bit more useful to the work environment. And now that my name is here, you can identify who I am, even though the class doesn't even say who I am. My name is not part of the variable name, but here I am, Chris. We can even do name first first and last. And we're going to add last to this. But the useful part is that we can create as many employees and then go about creating another one. Employee.m name last dot oops equals, I don't know, Sam, and second employee, I'll just use dot m name, oops, that should have been first. Sam equals, I don't know, Rockwell. I don't know where that came from. Alright, and then another dot m weight equals, I don't know, 150, got a 0, f dot m age equals, let's just say 50. Heard that name somewhere, but I can't put it. Salary equals 100,000 or a million, whatever that is. And then there you go. Now we have 2 employees here. We have me, we have Sam Rockwell. And in our employee, they have a first name, a last name, a weight, an age, and a salary. And then we could include all kinds of whatever we wanted in here. As much as you want in here, pretty much. You're limited only by how much RAM your computer has. And today's modern processors have tons, so you don't even have to worry about it in applications like this anyway. If you were creating like a game or something, you might need to shave off excess data here and there to save a few bytes, but that's only if you're making something that would literally stress out a modern computer. Okay, so we have all of this. Now, it would be a good time to introduce functions, because you'll start to see where the benefits of this are, other than just the abstract layer and how you can create multiple of the employee to really represent one, the idea of an employee. That's object-oriented programming. And then we're going to get into functions. So I encourage you to do what I did and design some of your own classes with your own data and try to represent them with numbers and strings. And remember that a string is really at its core a bunch of characters of type char. A string is just a class that manages many of these chars. So you'll see that really everything boils down to ints, floats, characters, things like that. So play around with it, create some of your own classes, and then do some stuff with them. And you'll learn more than you think just by tinkering with it.